Applications of forces, statics and particles. So we now look at examples which include friction. We know that the friction force opposes motion, and it has a value between 0 and its maximum mu r, which comes from this formula, where the maximum frictional value is equal to the coefficient of friction times the normal reaction force. And this is the maximum friction value when an object is about to slip. It's at limiting equilibrium. Example 1. A mass of 8 kilograms rests on a rough horizontal plane. A force P is applied at an angle of 60 degrees to the horizontal. The block wants to move towards the right, but because the surface is rough, there is a frictional force in the opposing direction. The whole system is in limiting equilibrium, which means the block is about to slip, so currently it's static, it isn't moving. So the frictional force here will be at its maximum value because the block is in limiting equilibrium. This value is given, the coefficient of friction. The resultant forces in any direction resolved will be 0 because the block is static. So F equals mu r. This will be the frictional force here, like so. To work out the unknown force P, we have to resolve forces in the horizontal direction and in the vertical direction. So force P gives us P cos 60 and P sin 60. Resolving vertically, this direction as positive, so we have P sin 60 plus R minus 8G equals 0. And then we can rearrange to work out R. Resolving horizontally, we have P cos 60 minus mu R equals 0, the resultant force, and we know what R is equal to, and we know what mu is, the coefficient of friction. We substitute those values in and solve to get P is equal to 42 newtons.